Our next video here from section 7 is going to jump a little bit in our notes. Right now my plan is to cover this chunk in class at some point. So just go ahead and scroll down a little bit till you get to the application problems. This says that we want to try to apply this inverse trig idea a little bit. It says the bottom of a 20-foot replay screen at Dodger Stadium is 45 feet above the playing field. As you move away from the wall, the angle formed by the screen at your eye changes. There's a distance from the wall at which the angle is the greatest, which basically means the screen looks the biggest. What is that distance? So the setup for this question, I want you to think a little bit about this, but if it's not quite clear, make sure you ask a question in class. If you were to be very, very close to the screen, almost like you're looking straight up at it, your view, what you actually see of the screen is quite skinny. And as you walk away, that screen seems to grow in height a little bit, and there's a point where it's the largest it can be as far as what you view. And then as you keep going, it's so far away from you that it starts to get small again. That's the idea here. We want to think about where is the optimal viewing area of this. So it helps to start out with a picture. So I'm going to attempt on my iPad here to draw a nice picture of the situation. We'll start in black here, I think. Let's say that you are standing right here. Okay, and this is the distance to that optimal viewing area. And so now we're at kind of the wall of Dodger Stadium. So you have to go up 45 feet. Let's say this length right here was 45 feet, and then I'm going to change color here a second. Let's say that this is the screen. Okay, so I know a few things. I know that this was 45. I know that this was 20. And then I want to figure out this. This is X. How far away do I have to be so that I've optimized kind of my viewing window? So let's try to get the viewing windows in here. Okay, well, from here, if this is my, I guess I really should say this is my eye level. But if I were to go straight to there, think of that as a perfectly straight line. And then from here, another straight line. The angle created there, that's my viewing angle. And I want to make that as large as possible. So it might help to think about a few other angles here. So first of all, I have this really large angle right here. I have what I'm going to call theta sub 1. And I have another angle here, theta sub 2. And I want to, if I can represent theta sub 1 in some way and subtract theta sub 2, I'm left with theta. And that's going to be my strategy here for the first little bit of this problem. Okay, let me get that number back up there of 45. Okay, so what are some things I know from my picture? If I were to stand at this point and I look at the largest right triangle, okay, I can use theta sub 1. That's this large angle right here, the whole angle, and I know something about the whole opposite side, and I want to know the adjacent side. So I know that tangent, different color here a second. I know that tangent of theta sub 1 is going to equal opposite, which is a total of 65, over adjacent, which is x. Okay, and if I look at maybe a smaller right triangle here, that's going to be using theta sub 2. I know that tangent of theta sub 2 should be simply 45 over x. Okay, so what I want to do here, I want to find theta, a way to represent theta. So to do that, I need to take both of these ideas and solve for theta sub 1 and theta sub 2. And if I subtract those two angles, I will have represented theta here. So how can I go about doing that? Let's see if I can squeeze this in here. I know that inverse tangent will take care of that issue that I have. So I know that if I just want to find theta sub 1, that's going to mean take inverse tangent of both sides. which would mean inverse tangent of 65 over x. And the same thing over here, that means theta sub 2 would be inverse tangent of 45 over x. Okay, so jot down questions if that's not quite making sense, but that's where we are so far. Okay, so what I want to do then is I want to figure out what is theta. Theta, again, is theta sub 1 minus theta sub 2. I know what those two things are. So if I want to find theta, I know that that's going to equal theta sub 1 minus theta sub 2, which, according to what I have up there, theta sub 1 was inverse tangent of 65 over x minus inverse tangent minus theta sub 2, which was inverse tangent of 45 over x. Let me just kind of split some of this up here a little bit. Okay, so this is something I can easily plug into my calculator. Maybe not easily, but it would take a little time, but I can. I'm going to do this in degrees, so I think that's a little bit easier to do. So I'm going to type all of this expression into y1 on my calculator, the whole thing. So y is going to be theta, and x would be on my picture the distance that I need to stand. So when I take the time to do that, I come up with a graph that looks something like this. Okay, give me a second here. Again, this is x, or distance, and this is theta, or my angle measure. I get something that does something like this. And all the way out to here is about 200, and I think I have this set at about 15. My numbers will be a little bit off, but I want to know where that angle measure is the greatest. I want to know where the y value is the greatest. So I'm trying to find the coordinates of that. So you just have to find a max, and the max for that, I already know, is approximately 54.08, comma 10.48. So as you can see, I made my maximum in my picture a little bit too high because I had my graph set as a max of 15. It really should be a little lower, but that's the general shape of it. Okay? So what is my answer then? I want to figure out the maximum. I want to figure out the distance that gets me the maximum angle. And my maximum angle is about 10.48 degrees, but it occurs at 54.08 feet. And that is my overall answer. Jot down questions, and we will see you in class.